today we'll be talking about towards reliability. And before we jump into it, I'm Jayesh. Ahire. I'm product manager here at Last Nine. I'm also AWS machine learning hero and Paleo champion. So if you want to discuss anything around machine learning or anything around systems, observability, reliability, feel free to ping me at Jayesh_1 on Twitter. So before we jump into today's talk, really, I wanted to talk about some of the things and set a context for it. So as you know, the world has been moving towards microservices and API-driven architectures from the more monolithic applications we used to use earlier. And this move has got significant benefits in delivery speed as well as scalability. But on the flip side, this has actually increased the workload for the teams as they have to deal with operational complexity while managing and monitoring monitoring and securing those new distributed architectures. Operating this distributed system is hard, but not just because of the complexity they bring in, but also because of the number of components, the distribution, and the unpredictability of the failure modes. There are so many unknowns, there are so many things to deal with. And one more part jumps in when you correlate all of these things to business and try to make your system reliable. So today we'll be talking about reliability. We'll be discussing how you can measure the reliability of your system and definitely improve it at one point. So before we jump deeper into the whole thing, let's just set the expectations and measurements. So every business which is into software, into tech, has some expectations from the product they're selling to a market, right? Like maybe even if it's a consumer product or even if it's a B2B product, there are some of the expectations business sets. And to measure if these expectations are being met or not, we need some measurements. We need some data to measure it. So let's just first see. I will start with a story. I will go through an incident, and then we'll understand what really the business expectations are and how do we measure if the system is helping to achieve those expectations or not. So, I used to work with this fintech org in the past, and one day there was a very big sports event going on in the country, and suddenly the payment request started increasing. And as the payment request started increasing, so the payment started failing. So, being a payments company, every second which was going into this whole failure was contributing to a loss, not just in revenue, but also in reputation. So the business folks asked engineering and ops about why the failure has happened. And the response was the payment services up all the time, and it's running. It's not down at all in the last few hours. So the whole fiasco was happening due to some third-party gateway failure, and essentially because of the payment success rate dropped in last few hours. So it took a couple of hours to figure the whole thing out, and in between, there was a significant loss in business revenue and significant loss in reputation. So the one thing which we mentioned, which we came across here, is the system was never down, but the impact was, but there was some part of the system which was impacted, which actually resulted in business being impacted. And how business reacted to this particular incident. So business reaction was there's a clear lack of a way to correlate the business impact with the incident because they were never able to understand what was happening in the system and how the unreliability of a system is actually impacting the business, actually impacting the revenue. And they definitely went ahead and blamed IT for the incident. Now, how ops or IT reacted to the whole incident? Ops went ahead and started collecting more metrics to avoid more of such incidents in the future. And they created correlations, they created more dashboards. Like one more graph on a dashboard we always create for the one incident, right? And I want one more alert syndrome take 10. And they also configured one more alert to get an alert whenever this particular part of the system breaks again. So was this a good resolution? We don't know. Like we will see if this was a good resolution or not. But there's definitely there's definitely some friction here, and this is not scalable at all. So before we jump into how to solve this whole problem, or before even we define what the problem here is, let's just see what the expectations are, and then we can jump into how we can measure them. So the business expectations are speed and quality of the system. And what business measures is speed and quality of a system, whereas the expectations are responsible and error-free services. So, while we're talking about measurements, apart from the speed and quality, the one very important thing which kicks in, which is even abstracted in the speed and quality, is revenue. Business measures everything in terms of revenue and the and impact on that revenue, to reduce the impact on that revenue. What it expects is the response of an error-free system or services which are running in that, which are running the application. So what ops measures? Ops measures a success with high availability, no resource exhaustion, and low cost of infrastructure. And what ops measures for defining the success is resources like CPU, memory, and disk. So how this whole thing results in? So like whatever ops measures and whatever the business expectations are, the ops measurement angle results in the huge metric collection and storage infrastructure and alerts which are going 24/7 and causing the alert fatigue. The metrics spread across multiple products. Like there are 10 different projects where the metrics are going. We are still trying to correlate everything. We are still trying to make sense out of the data. And there is no way to objectively measure your system. And measuring your system is very important because what gets measured gets improved. So what do we want out of this? We want a simpler, more reliable, more responsible observability, then again, we want everything to be aligned with business. And there should be faster paths to improvement. How do we go there? Definitely this is the ideal behavior, right? We having the simpler, more responsive observability. Everything is aligned with business expectations, and there are faster paths to improvement in the system. It's the ideal world, but how do we get there? So first and foremost important thing is we start collecting the right metrics. Or for that matter, if I want to be more abstractive, we start collecting the right data to measure the system. Then we monitor services and not really servers. And because in the modern systems, as we saw in the incident itself, the system was never down. It wasn't available. It wasn't responsive enough. So as the system was, and in the modern world, the system will never be down. There's always some availability zones. There's always some backup instances. Even if the Kubernetes, the HA, and all the stuff going on, so the system will never be down. It's more of impacted, and then the failures which are impacting the business itself. And focusing on service level metrics and service delivery will definitely improve the understanding of a system's behavior, and then provide us a faster way to resolve the issues if anything happens. So in correlation to the incident we discussed and the ways we got to go towards a more reliable system, let's just jump into the first topic, collecting the right data. So in the modern system, the system can visualize it as a burger. So there's a top layer, which is like ALB, ELB, CDN, everything which is serving the user request. Then below in the patty layer, there's application. The application which you've written, which is the business logic and the business logic basically, right? The application you wrote. It can be like, for this matter, like we are considering the Python application here. So the Python application you wrote with Django or Flask, or it's running in production. And then the below layer has databases like RDA, so messaging services like Kafka or RabbitMQ, and all those things running. But at a very lower level, everything is running on some instance. Even if you host your application in EKS, there's EC2 instance beneath that. Even if you run your RDS, like manage RDS, manage database service, there's a EC2 instance below that. So everything is running on some machine. So it becomes important to get the machine metrics to understand how the resources are being consumed or resources are running. So how do you observe an instance, first of all? We go to the application, but how do you observe an instance? So in the current scenario, you get metrics from CloudWatch for CPU, uptime, data stakes. You run a node exporter, you get metrics for memory, disk load, and also even if you are using Kubernetes, you can get the kubesec metrics for pods, network, and processors. And you basically get 9 charts for each metric per instance, which is huge. And I don't even know if I need those many metrics. So there's an open source project called Open Metrics Exporter, which we put out there. So what Open Metrics Exporter basically does is it collects metrics from all of these sources. There are modules which figure out what are the important metrics for RDS, like for this matter, maybe for EC2 instance in this case, and it just collects those particular metrics. It converts them to open metrics format, and can be consumed by any of your favorites. If you want it to be in Prometheus, you can do that. If you want it to be in if you want to send them Datadog or New Relic or any, or for that matter, even AWS, you can send them to that particular sync, and then you can visualize on top of it. You can create dashboards, whatever you want to do with these metrics. But again, this solves a problem for your resource metrics. The one major problem which is remaining is application metrics. So how do you observe your application? For observing your application, there are 3 kinds of data you can collect: metrics, logs, and traces. So for collecting the metrics, there are so many open source alternatives again. So there's Prometheus client library for Python, which you can use to observe your Python application, or there's even one CDK we wrote and put it out there. It's available in the open source. You can use that CDK. There are so many open source tools these days available. So here I'm using the CDK we created in open source, and basically it just generates the red metrics, the weight, like the call rate, the error rate, and the duration or latency metric for the Python application, and it exports those to your URL/metrics API, metrics /metrics URL, and then you can consume it anywhere. Then if you want tracing or traces for your application, you can basically, in Python, there are you can use the Open Telemetry library or Open Telemetry agent to generate the traces. The Open Telemetry library will help you instrument the application or the SDK itself, or if you want to auto instrument your application, you can use the Open Telemetry agent, and basically you can auto instrument the application, and it will generate the traces and kills and done. Logs, again, everything logs the information. Like the logs have been classically there since long time, so I don't have to talk more about logs. It's a detailed debugging information, very important when it comes to debugging the problems in your application. But today we'll be focusing more on metrics. Why metrics in the first place, right? So metrics are aggregated some of the statistics, and they are so valuable because everything from operating systems to application generate metrics which at least will contain some kind of name, a timestamp, and a field to represent some value. So metrics give us an easy way to track trends and alert on the deviations. So metrics in this case become the obvious first place to start with your reliability journey. So why we are focusing on metrics? So how can we use this metric going further? So when we talk about reliability, the second point I mentioned now, we have seen how we can collect the data. We can collect the right data. So now going more into the second part where we said you should measure services and not really servers. And we should measure the whole thing in the context of service delivery. So for that, we should talk about service level indicators. The service level indicator is a metric which shows how well your service is performing. And let's just align everything with the business goal again. So business goals are speed and quality, because if your system has speed and the quality, all of the other things are mostly satisfied. So how do you measure the speed and quality when it comes to a system? You can measure with latency. Like the good SLI choices here is latency, uptime, availability, and error. And what you shouldn't really measure, or what metrics you shouldn't really care about here, is resource consumption, cache hit rate, collection time, the garbage collection time. But why? Let's just talk about it. So what is a good SLI? A good SLI is an SLI which is very relevant to your service delivery, and it's very clear and unambiguous. So what do I mean when I say clear and unambiguous, right? So let's just go back to the previous slide and see, if I say my resource consumption for this particular service which I'm managing is closer to 93%, a business person comes to me and says, dude, this is not working well, what's happening here? And I'm saying that hey, the resource consumption for this particular pod has went from 50% to 93%, and that's why everything is uh, really breaking at this moment. So the person can't really translate this to the impact. Like, it's hard to correlate this to a business impact, and it's hard to understand how this impacts everything again. But if I go and say the availability of a system has dropped from 99% to 90%, it's easier to understand that the 10% requests are failing at this moment, and we have to do something there. Or maybe if I say the latency has went from 100 milliseconds to 300 milliseconds, it's a measurable impact, and it's easy to understand. So the good SLI is something which is very clear and very unambiguous. It's easy to communicate to all stakeholders. You again saw in the current example itself, when I say the availability went down, it's easy to understand, it's easy to communicate, and it can even be understood by the non-technical people in the organization. So SLIs basically create a common language for entire organization to measure the performance objectively. And while I'm saying measuring the performance objectively, I'm definitely setting some objective on top of my SLI, and that's where the SLOs come in. So SLO here is a goal for your SLI. So if I'm running a Django application, and my latency for the application 100 milliseconds, but my goal is 50, that becomes your objective for the SLI. You want your latency to be 50 milliseconds. We'll go deeper into it a little bit. So SLI for this matter is a latency here. So the difference between SLI, SLO, and SLA, right? The SLI is latency. The SLO is my latency should be below 300 milliseconds 99% of the times. And the SLA defines what if it is not below 300 milliseconds 99% of the time. So SLA is something two businesses are promising each other. So if I'm saying that I'm a payment gateway, and if the more than 99.99% transactions fail, which are going through my gateway, what will I do? Like, I will give you some discount or something else. That is defining the SLA. So what is a good SLO for that matter? So the good SLO can be defined as a latency should be below 300 milliseconds 99% of the times over a period of 7 days. If me as a business is defining that latency for my application should be below 300 milliseconds 99% of the time over the period of 7 days, it's very unambiguous, and it's very easy for ops and engineering to understand what I want and then implement that in the make sure the code they are writing, the pipelines they are setting is actually adhering to this particular SLO asset, or is not breaking this particular SLO. So let's just break down and understand what are the parts of these SLOs, right? So the latency here is the SLI, as we discussed. It's a service level indicator. Now we are saying it should be below 300 milliseconds. So below 300 milliseconds is the objective for my SLI. 99% of the time is a compliance target for my SLI. And over the period of 7 days here is a compliance duration for my SLI. So SLO, so it's basically the latency should be below 300 milliseconds, the objective, 99% of the time, the compliance target, and over the period of 7 days, the 7 days being the compliance duration. So how do you set a SLO? Setting an SLO is very easy. You first identify the business impacting SLI, then you set a threshold for that SLI, and then you select a compliance window and compliance target, and then you go and configure the alert channel. So whenever your SLO is under threat or your SLO is breaking, you will receive an alert, and you can take a stab at addressing that or solving the problem. So going ahead a bit, I will walk you through an example of setting an SLO, and then we will, at a very high level, discuss how this all comes together to help you measure the reliability of your system. So suppose I want to create an SLO. There's this free tool we have created, more of an educative tool for that matter, to help you understand how to set an SLO. And on the right-hand side here, you can see like how it contains all of the context. It has all of the data which you might need to for setting an SLO, right? So suppose I want to create an SLO for service XYZ. So I'm creating an SLO on the uptime metrics. I'm naming it uptime service XYZ. Then I go ahead and select a metric. So now, as you might remember from the previous ones, we collected metrics for the application as well as resources. And now that I know that what metrics are important, like the uptime, the SLIs like uptime availability, I will try to write a prompt expression in order to get those, in order to get that particular SLI for maybe availability, maybe uptime, right? So in this case, I'm going for uptime. So I said sum of up, and I can see the latest 20 values. It's mostly around 29 at this moment. So this is the metric I selected. Then the SLI expression, which you talked about, the target for your SLO, the target for your SLI. So if I say it should be less than 28, the sum of time should be sum of up should be less than 28. I can see over the last 2 hours, I'm not really reaching the target right now. So I should really set it little higher at this moment. Maybe I'm not able to achieve X less than 28 or the sum of up is less than 28. So I went ahead and said X should be less than 30. And I can see for last 2 hours, it's not breaking, it's 100%. So let's just go with it. And the next thing becomes, as we define in the workflow, it's selecting the compliance duration, or compliance period, and the compliance target. So compliance period can be something 1x or 2x of your sprint cycle, so that if any bugs have been introduced in the sprint, it shouldn't affect the area budget for the next sprint, right? So we are setting it 7 days or 14 days as per the sprint cycle. And the compliance target, you can set it to 99, 99.99, whatever you like, whatever is achievable at this moment. So ideally, like you can set aside an area budget, and accordingly you can set the compliance target. And if you are able to achieve 90% at this moment, start with 90 and slowly upgrade to 95 and 99, 99.99. So this creates ladder for reliability of your system. Once you set the 7 day and 99.999, I'm setting like this is very very high for a compliance target, but you should be able to start with 90, 95, 99 for that matter. Then I go ahead and set a notification. I want a notification when there's a threat to my SLO, and I want a notification when the SLO has been breached. And I create a SLO and I start getting alerts. So how this all now comes together for reliability of the system. Just go back a bit. So how all of this comes together for reliability of the system. The first thing, we collected the right data to measure the reliability of the system. So we started collecting right metrics. When we started collecting right metrics, we started understanding trends across my system. The second thing, I started measuring for my services instead of measuring for my servers, because in the modern world, the servers will always be there. What you have to care about is the impact on the services. So I will start measuring for my services, and the next part becomes, once I start measuring for my services, improving the reliability for my service. So I have to start objectively measuring the service, the key SLIs for my service, like reliability, the latency, the uptime, the error rate. I start objectively measuring my SLIs, and eventually I jump the ladder of nines and reach to a 99.99% availability for my service, or 99% or 99.99% times my latency is 1100 milliseconds. I reach all of those objectives. So the speed and quality of my system is attested. The speed and quality of my system always remain consistent. And so I'm delivering a good user experience, the good customer experience all the time. So that's where this whole story comes in. This whole story gets you towards reliability. And I will just go back to a slide where we said whether. So we collected the right metrics, we monitored services and not servers. We focus on service level metrics and service delivery. And it will help you to measure reliability objectively and slowly get towards 99.99%. So if you want to learn, more about the metrics, how to export using the open metrics format, SLOs, or how do you measure your SLOs, the registry, OpenMetrics registry, and all that stuff. I have linked all the important blogs and GitHub repositories here. So please feel free to go through them. And if you want to get started like with OpenMetrics Exporter or contribute to OpenMetrics Exporter, I haven't talked more about it, but feel free to reach out to me on the email ID I will share afterwards, and I will be happy to discuss more. But if you want to contribute to the open source project, go to the github.com/last9/OpenMetrics registry, and we have everything available out there. So you can feel free to use it. If you have any suggestions, raise an issue. If you have any use cases you want to discuss, feel free to reach out to me. And if you want to play around with the SLOs, learn more about SLOs, you can use the SLO computer. It's again a free and education tool. So you can start learning with that. Go to app.last9.io/SLO and you can start playing with the SLOs as well. So yes, and I promise Calvin that I will finish in 30 minutes, and it's close to 30ish now. So thanks everyone for joining in, and if you have any more questions, Calvin will obviously go through if you have any questions in Slido or Slack. But if you have any other questions, please feel free to reach out to me at Jayesh_1 on Twitter, or drop me an email on jayesh@last9.io, and I will be happy to help with jumping or maybe like flying your plane towards reliability. So thanks.